Morning, geometry class. I hope you're doing fine today. We're getting ready to finish up the last new lesson of the whole school year, so that's pretty cool. I'm proud of you because you're here and you're ready to pay attention. There will be keywords today, so look for them. And we're going to take a look at how you can find an angle if you are given what the sine value already is. If you have not watched part 1, this is probably going to make no sense, so please go back and watch part 1. Okay, so here we go. So here we are given the value of the sine. So you might have put in the fraction, you might have turned it into a decimal, but we know the value of the sine of A, and we want to find the value of A. Once again, your calculator holds those values in a chart inside of it. So what you need to do to access it is that you need to use an inverse, okay? The inverse, if you'll notice, is the yellow writing, and I believe it's blue on the TI-84, but the second of the sine button gives you the inverse sine, and it'll look like this, and then you'll get this value. So you'll press second sine, and then if we wrote it out, it would look like this, the sine inverse of 0.2159, and you'll get that value. Now, let's be careful, okay? Because like I said before, especially if you're using a simulator, it defaults back to radian measure. You need to make sure that you are in degree measure. If you're using your own personal calculator, it's not going to change up on you, but you need to make sure you're in degree measure. And then we're going to use inverse. By the way, your first keyword is inverse. Please write down inverse as your first keyword. So you'll push second sine. I know the graphic was already there, but just so you see it again, 0.2159. And then that will give you 12.5 if you use the rules of rounding. I'm going to say just so that we have a standard in our class, we're going to round it to the 10th place when you're finding the angle measure, when you're finding the number of degrees. If you'll notice, atop of the cosine and atop of the tangent, there are also those inverses. So if you're trying to find a value of an angle, and you're given the cosine or you're given the tangent, then you need to do the same thing, but use second and cosine for the cosine one, and second and tangent for the tangent one. And always use the rules of rounding. Both of these get rounded up. Your second keyword is second, because you need to remember to find the inverses, you use the second of that function. All right. Well, you say, well, what about that calculator? Let's take a look at this calculator. It is in scientific mode, and I wanted to find of 1.9277, and I want to find the sine. That we have a second button here, so you need to do not sine on that one. Wait a minute, that's tangent. Second tangent, notice it has the tan with the little -1. That's the inverse. 62.58 gives a lot more digits in this one. Actually, we don't really, like down here, it's not going to make any difference to us, but 62.6 for your answer on that one. Your phone calculator, play around with it a little bit until you're getting the same numbers. And as I said multiple times before, please make sure you get the right calculator for next year, because there are things you won't be able to do without it. Okay, so now that we know how to find the angle, if you know what the sine or the cosine or the tangent is, we can solve triangles that haven't been given any of the angles, but just two of the sides. Our key thing that we need to do, well, we first need to figure out what we're looking for. We're looking for angle A, angle B, and the missing side. You're always looking for the three parts that aren't given. In yesterday's lesson, we were given an angle and a side, so we looked for the other two sides and the angle. Here we're looking for the angle and the missing side. So your key first thing to do is label. That's your third keyword. We need to label everything. Figure out which angle you want to find first. You have a choice. You could figure you want to find angle A or you want to find angle B. But once you've figured out which one you want to find, you need to label appropriately opposite, adjacent, and hypotenuse. Hypotenuse, longest side, as you know. Opposite, the one all the way across the triangle. And adjacent is the one next to it. Notice I have the 3 and the 8 circled because those are the numbers. These are the ones we have actual values for. Notice it is an opposite and it is an adjacent. These are the numbers we're given. Let's go through sine and cosine and tangent. Sine is opposite over hypotenuse. That's not going to help us because we don't know the angle. We don't have enough information. Cosine is adjacent over hypotenuse. Once again, not enough information because we don't know the number of degrees. However, tangent, opposite and adjacent. Okay, we have both of those numbers. We have something to work with. So that tells us that the tangent, opposite over adjacent, SOHCAHTOA. Remember that to help you remember. Tangent, opposite over adjacent. So when I want to find the measure of angle A, in one step, I can put the inverse of tangent of 8/3. So I can use my TI-83 plus and I can do second tangent. Okay, it turned off. There we go. Second tangent of 8/3. And I get 69.4 degrees, about 69.4 degrees. I didn't have to convert the fraction first. Now on this calculator, we might have a little bit more trouble. We may have to convert the fraction first. I'm going to clear this out, make sure everything's gone for that. And I want to take 8/3. Okay, and then I want to do trig, and I need to do the second of tangent, 69.4. You get the same value there. So either way, if you're using another calculator, play with it a little bit. So I now have angle A. That's good. Angle B follows very quickly, nicely after it, because all you have to do is take 90 minus 69.4, because we already have 90 left over from our 180. So 90 minus 69.4, 20.6. That's our angle B. Now what about AB? If you wanted to, you could do something with trig, with sine or cosine or tangent, but it's much easier at this point to use a Pythagorean theorem, a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. So 9 plus 64, 73. We need to square root it. But especially in the case of solving right triangles, most of the time it's good to get an approximate value. So let's review how to find that on your calculators. We need to do the square root of 73. Oops, if I can get that second 73. Okay, so we have about 8.5. So just in case though that you did not write the word label down, make sure you write the word label down. That's super important for doing these processes, the labels. So that was your third keyword. All right, let's look at another one. This one has different numbers. We need to find angle Q, angle R, and segment RS. We need to figure out where our opposite, adjacent, and hypotenuse are. Notice I labeled Q as a lowercase across from the uppercase. This Q represents the length of the side. This Q represents the angle. Okay, 11 and 15, super important. I'm going to try to find angle Q first. The opposite side is here, the hypotenuse, and the adjacent. Once again, we're labeling everything. Angle Q, not side Q. Angle Q, these are our two values. We have an adjacent and a hypotenuse. Let's think through. Sine is opposite over hypotenuse. Nope, that's not going to get it for us. Cosine is adjacent over hypotenuse. Yeah, that's it, because adjacent and hypotenuse are the things that I'm given. 11 over 15. Then use your inverse key. Okay, we've been practicing that. So second cosine, 11 over 15. So you see it once more. So 42.8. Angle R, remember, you're just taking 90 minus that. All right, so we have angle Q, 42.8 degrees. Angle R, 47.2 degrees. RS, A squared plus B squared equals C squared. 11 squared plus Q squared equals 15 squared. Multiply it out, subtract 121 from both sides, and do the square root of Q. Square root of Q squared, sorry, square root of 104. Oops, like that. And I can do that this way if we need to. 104, if you want to do the square root in this type of a calculator, you know, in these things you're always doing everything, put the number in first and then the operation. In the TI 83 and 84, it's a little more natural because you're actually doing the operation in the order that you would figure it would go in. Like, for example, square root of 104. Like that. So about 10.2 in both ways. Okay, now take a minute right now. You can either take a picture or however you handle your notes. We have a word problem to think about, because this is where it can become useful. And you want to make a sketch. That's your fourth keyword, sketch, when you have a word problem, because it helps you. So the angle of elevation between an observer, okay, the person who's watching, and the top of a tree is 52 degrees. So you're picturing you as the observer looking up at the top of the tree. It's a tall tree. You want to get an estimate of how high it is, because you might want to hire somebody to come and remove that tree. We had to do that at some point, and they come out and do their own estimates, but they do take into account how tall the tree is. So you can, if you figure out your numbers ahead of time, you know if the person is being truthful with you or not when they tell you, well, this tree is so tall. So you can kind of do an estimate. Okay, so 52 degrees, the observer is standing 35 feet from the tree, and his eyes are 5.5 feet above the ground, because your eyes are not on the ground while you're observing the tree. You're not laying down there. You're standing up. You're looking at the top of the tree. So making a rough sketch of this situation, here's our tree. Here's the top of the tree. 5.5 feet where the eyeballs of the observers are looking up at the top of the tree. Okay, and 35 feet from the tree. And you want to find the height of the tree. The height, though, is not going to be just this piece. It's going to be this piece plus the 5.5 feet. But we want to find this piece of the right triangle first, because bringing the angle down here would be difficult and unnecessary. So we're trying to find the height. We still need to label our opposite and our adjacent and our hypotenuse. Our opposite is this H. There's the adjacent. And here's the hypotenuse. 52 degrees. Okay, we know the degrees this time. That makes it easier. We're trying to find the opposite and we're given the adjacent. Opposite, adjacent. That means we're going to use sine is opposite over hypotenuse. Not going to help. Cosine, adjacent over hypotenuse. Not going to find help. But tangent, opposite over adjacent. Yes, that's our thing to use. This time you're not using the inverse of tangent. You're just using tangent. So you're just finding the tangent of 52. Okay, 1.2799. Then you can multiply both sides by 35. Answer times 35. 44.8 is about the height from here to here, but keep in mind that your eyes are 5.5 feet above, so we have to add that 5.5 on there. So the tree from the bottom to the top is 50.3 feet tall, and that's a good use of this because you wouldn't necessarily want to climb up there, but it would be useful to find out how tall it is sometimes. So there's that. That's the end. And I'm praying for you guys, and I hope that you have a very good and blessed day.